Wave motion. In this presentation, we'll discuss wave motion, particularly transverse wave motion and longitudinal wave motion. Through the space, when a particle moves, it carries some kinetic energy with itself. The energy associated with the particle goes with it whenever it goes. In this visualization, we can see the kinetic energy goes with the particle. Thus, energy is transported from one place to the other together with the particle. There is another way to transport energy from one part of space to the other without any bulk motion of material together with it. The motion of a particle under different conditions is different. In an elastic medium, a large number of particles are linked with elastic connection between them. Now, how can we define elastic medium? A medium such as air or water which can change in shape as a result of a deforming force and which returns to its original shape when said force is removed. If periodic motion is passed on to any of this particle of a medium, then the energy of motion of this particle will be transferred to the adjacent particle and this particle will start the similar periodic motion. This particle will in turn transfer its energy to the neighboring particle and so on. In this way, the motion imparted to the particle will move uniformly to all directions from particle to particle with a definite velocity. In other words, a disturbance of this kind is propagates from particle to particle due to transfer of energy, and this is known as wave motion. In general, wave motion is a form of disturbance from an equilibrium position that travels through an elastic medium with time from one region to another. It is a kind of disturbance that travels through a medium due to repeated vibrations of the particles of the medium about their mean positions. It is a mean of transferring energy and momentum from one point to another of the medium without any actual transportation of matter between the 2 points. Now, how can we define periodic wave motion? If the disturbance is continuous and is periodic in nature, then the wave produced is termed as a periodic wave. A periodic wave that is varying sinusoidally is called sinusoidal periodic wave. The particles of the medium execute simple harmonic motion when a sinusoidal periodic wave passes through the medium. Now, characteristics of wave motion. In wave motion, the disturbance travels through the medium due to repeated periodic oscillations of the particles of the medium about their mean position or equilibrium position. Energy and momentum are transferred from one point to another without any actual transfer of the particles of the medium. There is a regular phase difference between the particles of the medium because each particle receives disturbance little later than its preceding particle. Now, classification of wave motion. Wave motion is classified on the based of medium of propagation and number of dimensions a wave propagates energy. Mechanical wave, non-mechanical wave are the types of wave motion which are based on the medium of propagation. Number of dimensions of wave propagation according to energy is classified into three parts: one-dimensional, two-dimensional and three-dimensional. Now, wave motion is classified into two parts: mechanical wave and non-mechanical wave. Here, for mechanical wave, medium is required and medium is not required for non-mechanical wave. Again, mechanical wave is classified according to the vibration of particles of the medium and based on the energy transfer. Based on vibration of particles of medium, again classified into two parts: transverse wave motion and longitudinal wave motion. And mechanical wave based on energy transfer is classified as standing wave and progressive wave. Now, particular mechanical waves is defined as waves that required a medium for their propagation are called mechanical waves or elastic waves. The particles of the medium execute periodic motion about a mean position when the wave propagates through the medium. For example, waves on string, membrane of drum, light and sound. Properties of medium of mechanical wave propagation. The medium must possess inertia, that's why particles of the medium can store kinetic energy. The medium must possess elasticity as well as the frictional force must be minimum between the particles of the medium. Now we know that mechanical wave is classified into two parts: transverse wave motion and longitudinal wave motion. Transverse wave motion is defined as a wave motion in which the particle of the medium vibrate about their mean position at right angle to the direction of propagation. For example, electromagnetic waves and the waves on the string. Transverse waves commonly occur in elastic solids. The oscillations in case are the displacement of solid particle away from their relaxed position in directions perpendicular to the propagation of the wave. Now we'll discuss the next type of mechanical wave motion. It is longitudinal wave motion. It can be defined as a wave motion in which the particles of the medium vibrate about their mean position along the direction of propagation. The standard example of the longitudinal wave is sound wave or pressure wave in gases, liquids and solids, whose oscillations cause compression and expansion of the material through which the wave is propagating. And the last one is non-mechanical wave. The waves which can propagate without a medium are called non-mechanical or electromagnetic waves. For example, light wave, radio waves, X-rays, gamma rays, etc. Thank you.